All right, so let's take a look at these examples. First one, a coffee machine dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the number of ounces measured in a random sample of 20 cups. Is there convincing evidence that the machine is shortchanging its customers? All right, so anytime they say, is there convincing evidence, what are we going to do?
Make a null hypothesis. Oh, take a test.
We're going to do some sort of test, which involves doing the null and the alternative hypothesis. So do you want to do the hypotheses first?
No, sir.
You don't?
No,
I
we
would
want
like
to
to
do
do
the
the
conditions.
Okay, that's fine. I don't mind. So
Sweet.
what are the conditions that we need to make?
Random.
All right, so per the problem, this is a random sample.
This test is going to take a long time.
Yeah, we should have like 3 periods to do it, Mr. Davis. Nope. I think it's a no. Gotcha.
All right, what else?
Less than 10%.
All right, so we are drawing from a population, right? So we don't really know how many cups of coffee this machine puts out, do we?
No.
But we'll assume that 20 cups is less than 10% of all the cups of coffee that this machine has produced. So the 20 cups of coffee in the sample.
Bless you.
Is less than 10% of all such cups the machine has made.
Where's Ariel?
I'm sorry,
Do you know where Ariel is?
she's sick.
Oh.
She's fine, that's it.
Yeah, I've had lots of kids that have either had the flu or have the flu, so I'm hoping that she doesn't. All right, what else?
Do we have to do?
The histogram?
Yeah, we need to know that our sample is somewhat normal.
So that's always for means that we need to know that.
Yep,
And if we're doing proportions, that's when we have to do success failure.
correct.
So then we don't ever have to say something like, oh, it's independent, right?
The 10% is to ensure independence.
Okay. We don't have to like explicitly say it. It's kind of like assumed we say it.
Yeah, by saying that you fulfilled the independence clause.
Right.
By saying that it's less than 10%,
Oh, yeah.
our sample is less than 10% of all, we're doing the independent part.
That makes sense.
All right, so let's put these numbers in. So I'm doing a test with one mean. I'm going to do a t-test because it's a small number. If it was a lot, I might do a z-test and it'd be about the same. Remember we did that yesterday.
And 30 is the.
Sort of 30 is the, yeah, when we get to that point, they're basically indistinguishable. Oh, hang on a second.
Watch him give us 30 on the quiz.
What?
I said if he gives us 30 on the quiz, I'm not gonna know what to do, Mr. Davis.
So I feel like I'm sorry?
We have to go into statistics.
To find a histogram, right?
Yeah.
Yeah, but yeah, because we're gonna have to look at it anyway. So the nice thing is with this one is when you clear these out, you never accidentally get rid of it. On the TI, if you hit delete instead of clear, it gets rid of L1,
Oh yeah.
and it's kind of a pain to get back.
Oh yeah, I remember that.
I don't think I've ever heard it either.
Yes, y'all have. This is ridiculous.
Wow, she just called us both liars.
I'm gonna play the song. It's like, it starts off funny. It's like a funny song.
It starts off funny.
It's a great day to be alive. I'm pretty sure is what it's called. Great day to be alive or something. By what's his name?
Big Daddy Weave.
Oh, that's me.
Randy or
That boy Randy.
what's his name?
Oh, Randy. Yeah, I know him.
What a name, Randy.
His name is gonna be Randy, and then y'all are gonna be like making fun of me for no reason. Travis, it's not Travis Trey. It's something like
Scott.
no. It's Randy. I told you.
Randy.
So last time we looked at the
Whoa, why
What?
is it
Yours
yours?
looks
Yeah, mine's
Yours
not.
looks way
yeah,
different.
because I accidentally typed 0.0 on one of them.
That'll do
Now
it,
it's
Mr. Davis.
Mr. Davis.
Mr. Davis.
Okay.
No, not ringing the bell.
It's actually depressing. There's so much culture.
This making me mad.
Yes.
No, this. Why don't I do this?
No, she was wearing a sweatshirt.
I know, I do it while I wear a sweatshirt too, so that's how you know I'm not doing it just for the. I literally.
Sure.
Well, that time I was doing it to mess with you, but I do it without with a sweatshirt on.
Yeah, me too.
Huh?
It's more nice when I do it.
I know. Please do it so I can see your huge muscles.
I think it's the 8.7. No.
Can you pop this freaking machine gun?
Oh, it's supposed to be 9.7.
Yeah.
Go.
There's 8.
Where's Aya?
All right, let's try that again.
Oh, it still looks different. Yeah, it does a little bit, but it's okay.
Oh yeah, just a little bit.
It's pretty normal though, right?
We can check the other one to make sure, right, Mr. Davis?
Yeah.
Oh no.
The normal probability plot. Ooh,
Or we could look at a box plot.
oh, that too.
Yes, this is decent.
Box plot looks pretty good.
For show.
If we look at the normal probability plot, it should look pretty straight. Yeah, that looks pretty straight.
Good job, Keith. That's really good.
So with any of those, and now if you're going to reference the histogram, you usually draw the histogram real quick. Okay. I don't know why my histogram is doing weird things.
Oh, so we'd have to like draw off the histogram just to say like because it looks like this, we can use a model. Or...
Yeah.
I think you're like one off or something, because it's like one bar is different. Because those two on the left shouldn't be close together. They should be like openly spaced. Yeah, that one.
All right. So it's probably my data someplace. Man, that's small. 9.9, 9.7, 10, 10.1, 9.9, 9.6, 9.8, 9.8. So far, so good. 10, 9.5, 9.7, 10.1, 9.9, 9.6, 10.2, 9.8, 10, 9.9, 9.5, 9.9. That's
That's weird. I don't know. It's just that one box.
interesting.
Mine has that too, so
Yours has what?
like the gap in between the box.
Well, I don't think I missed any of the numbers.
I don't think so.
Regardless,
It's still pretty normal. Yeah.
yeah, and I'm actually going to. I don't like the big gaps here, so you can actually go into the settings.
And remove that.
No, what you can do is go, okay, it has a bin width of 0.05. I'm gonna make it 0.1.
Mm. Wait, so technically you could just play with it, and it could technically at one point look normal, depending on your bin width.
Well, no.
Oh.
If it's bimodal, it's never gonna look normal no matter how many, how small you make your bin. But this, to me, is a better bin width.
Yeah.
Yeah, I do have issues sometimes with their bin width on this. I asked my guy about it, and it's a whole discussion. But anyway, all right. So, in the interest of time, and I'm sorry I took up so much to do that, we'll say that the histogram of the sample is free of skewness or outliers. You can even, in some cases, if it's slightly skewed, you can say it's free of strong skew, right? So it's relatively normal. So the conditions have been met to do a what?
One proportion or one population Z interval test.
One mean.
Oh, yeah.
Well, if you have trouble remembering, the nice thing is, yeah, because your calculator actually tells you the name to perform a, and you're like, okay, what is that called? And you go down to the inference. You go to tests.
One mean Z test.
Yeah. A one sample test for mean, and we know that it's going to be a t-test, so this is a one sample t-test for means.
So, not all the beginning units, but like the beginning units about when we were learning histograms and stuff and like skewness, on the actual AP test, were those units just like background or like?
No, they still ask you questions about
Oh,
those.
okay.
Yeah. Yeah, it's not, we were just building up to
To
this.
this, yeah, okay.
Yeah. All right, so,
Hypotheses.
all right, so our null hypothesis is what?
Equal to 20.
What's equal to 20?
Your mean.
Your mean,
Oh, no.
mu.
Yes, mean.
Mu is equal to 10. I don't know where you got 20 from.
Oh, sample 20.
There were 20 samples. The alternative hypothesis in this case,
Is less than 10.
less than 10, where mu
Oh, no.
is the mean number of ounces dispensed by the machine per cup. And we need to set an alpha level.
0.05.
Okay. So now let's do the test. So our null hypothesis is that we're equal to 10. Our alternative is that it's less than 10. We're going to use a data set. Hopefully that's the right one. So let me read these again and see if you guys can figure out where I went wrong. So 9.9, 9.7, 10, 10.1, 9.9, 9.6, 9.8, 9.8, 10, 9.5, 9.7, 10.1, 9.9, 9.6, 10.2, 9.8, 10, 9.9, 9.5, 9.9.
I got the exact same.
Yeah, I got the same thing.
Okay. So our significance level is there. So did you guys get that our sample average is 9.845?
Yes.
Okay. So we need to report that. The standard deviation for our sample is 0.199.
And when it's the standard deviation for our sample, it's just S equals, right?
Yeah.
Whereas standard deviation for the whole thing would just be SD.
It would be sigma.
Or sigma, yeah.
0.199, yeah. What else does this tell us? We know the sample size is 20.
And the p-value.
Our t-value is negative 3.5 about.
So what does that mean again? The t-value?
It's just like a z-value.
Okay.
Like a
It's how many t's it is over.
So it's 3.5 t's below.
Below the mean, right? Which makes sense. We know that this is below what we purport the mean to be, right? All right, and then let's see, is there any other information that we can glean from this? Oh, the p-value. Look at that tiny little p-value. So the p-value is 0.001.
Yeah.
Yeah. Which is certainly less than alpha. Therefore, what are we going to do?
Reject.
Reject the null.
Yeah, therefore we reject the null.
So do we have to write that part out?
That part.
Like the p equals 0.0?
Yeah, you got to tell the p-value.
Or like I put p-value equals, but then can we say like with the p-value this low?
I would say specifically, if we have an alpha level, I would say use the alpha level. It's less than alpha.
Okay. But we can write it out in sentence form, not like.
Yeah.
Okay.
We reject the null. There is convincing evidence. And I'm going to I circled it and said, yeah, write all that.
And so like I know we'd have to draw up the histogram and whatnot, but like if we did the other thing where it's like normal,
The normal probability plot.
we just have to say it.
I think I'm gonna have to look that up
Okay.
because I've always just drawn the histogram.
Yeah.
It doesn't take very long.
Yeah.
So do you have to write like the point, like the bin widths too, and all that, or can you just like?
No, I just drew the shape of it.
Okay, good. Okay. But that is points off. We don't actually draw the histogram. We can't just say it's
The histogram appears normal. You need to show what it looks like.
Okay.
Yeah, so on the last one I know we said something, I think they kind of just asked this. The what's it called? Hold on. The normal probability plot. Because on one of them, our normal probability plot was straight, but our histogram was kind of weird looking. Like on the problem we did on our packet. So how do we say?
It wasn't all that weird looking. We'll go back to that.
Okay.
So let's create, and I'm going to add interpret a 95% confidence interval for the mean amount of coffee dispensed by the machine per cup. So finding the confidence interval is just a matter of using your calculator.
Really?
Duh.
I love that. Just click a few buttons and you're there.
So we're going back to the intervals. We're doing a t interval. We're using a data set. The data is already in there. They wanted a 95% confidence interval, which matches our alpha value of 0.5. So we already know most of this stuff, right, from the previous one. What we don't know is what the T critical value is. That we didn't know.
Mhm.
So we'd probably want to report that as T crit is about 2.1.
Even it didn't really ask for it, you still want to.
Yeah.
Okay.
I tend to anything that it gives me that they didn't in the problem give me, I tend to write it down.
Okay.
Wait, so how is that different from the other T that we got? Where it's -3?
So this is so here we're looking at if the mean really is 10 and we get a mean of 9.845,
Yeah.
how many T values is that to the left or the right from
10.
the original? As opposed to this, your T crit, you use that to, if I want to capture 95% of the data, how many T values do I need to have?
Oh, okay, so that's more like a Z-score with like standard deviation is 1 and mean is 0, in a sense. Whereas the other one is more about like you're using an exact amount. In that case, it was 10.
No, not quite, but sort of.
Group out.
But this is like the Z crit that we used for,
Yeah.
right, for whatever. So this is if you have 19 degrees of freedom in a T,
Yeah.
and you want to capture 95% of the data in the middle, you need to go 2.1 T's to either side.
Okay, that makes sense.
Yes.
Okay? All right. I don't usually bother with standard error for that, but I will say that it has 19 degrees of freedom.
Even though we already put that? Oh,
We didn't.
I put it, sorry.
Oh. Did it tell you that on the other one?
Yeah.
And we just didn't write it? Bad teacher. Bad.
Does that count? That's 1. Woo.
So it's from 9.75 to 9.94.
So they were lying. Which one was lying?
Nate's upset.
Well, we don't know that they're lying. What do we know?
That 4 samples of this size, we are 95% confident that it is lower than 10. Period.
So we're 95% confident that the mean number of ounces,
So we don't say average mean? Well, that means means average.
yeah,
Duh.
dispensed by the machine is between 9.75 and 9.95.
Which is all below 10, so it definitely was lying. Not lying, but like definitely is shorting us.
Well, we don't know definitely.
Not definitely, but it's more than
We're
likely.
95% sure.
Yes, that's all it takes for me.
Yeah.
No, but I see what you're saying, Mr. Davis. Definitely is the wrong term.
It's a little bit like in the Super Bowl where Tom Brady kept saying, "But anything could happen," and I'm like, "No, this game is over."
Oh yeah, I think he was just saying that because I think he wanted the Chiefs to lose, in my opinion.
I think he did too.
Because
Keep his title as the GOAT.
oh,
It's different.
Yeah.
I'll debate about that till the day I die. By the way, no.
Oh, I don't think that. I don't like what this
All right.
is.
Moving on to number 2.
Sorry.
That's all right. I started it. So a company has set a goal of developing a battery that lasts over 5 hours, 300 minutes in continuous use. A first test of 12 of these batteries measured the following continuous use lifespans in minutes. Blah, 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 blah. Is there evidence that the company has met their goal? Okay, so we want to know. So,
It's not random.
Yeah, it's not.
okay,
So
so
we can't do the problem.
Oh, over.
we actually can,
Oh,
but we're gonna note that this is not just a random sample. Okay, although
Me on the test. Doesn't say it's random.
This is not given to be a random sample. Of the batteries, we will assume that it is representative of those batteries.
So that's what we can say if it doesn't state that the thing is random. We can just say we'll assume it's representative of.
So basically what we're noting is that it doesn't say that it's random, but we're going to go, okay, we don't know for sure, but we're going to assume so we can go ahead and do the test.
Okay.
So isn't it kind of like contradictory to say that it's less than 10%? Like, so each one's independent, or sorry, your sample size is small enough to be independent from one another, but it's big enough to be representative.
So, yes. So those two things are always in tension,
Okay.
right? If you take too big a sample, well, now they're not independent of one another.
But they're really representative, or more so representative.
Well, yeah, they start to be, and at that point, you're like, okay, I'm not going to do this anymore. I'm going to do all of them and do a census instead of a sample.
Okay.
But then, that becomes an awful lot. All right. We will likewise assume
It's less than 10%.
yeah. But even if it's not less than 10%, we've said that it's a representative sample. And that's why we want to have a random sample, because we want it to be representative, and we want it to be independent because we want it to be representative. Is less than 10% of this type of battery. So I think you could actually leave out that second sentence, because you want a representative sample.
Yeah.
And so to get a representative sample, you'd like it to be random and you'd like them to be independent.
So saying the word representative counters both of them.
It does. All right. So let's put this in and see what this thing looks like. So I'm going to clear all these out. And put these in. Oh, we're out of time already? Wow.
I'm pausing. You're having fun, Mr. Davis.
I have to rein in our conversations some more.
Yeah. Parody.
Oh, okay.
It turns out, just so you know, on this one, that the p-value is 0.237.
237. Oh, so that's 23%.
So we're going to fail to reject the null.
Yeah, so it's not.
So they haven't met their goal.
So there's insufficient evidence to conclude that the average lifespan is over 5 hours.
That's so
It
sad.
Well, it turns out, first of all, it's a pretty small sample. It's only 12. And it turns out that the average in the sample is 306.
So when we're writing the null, or when we're writing the hypothesis, the null would be it's equal to 5, and then the
It's equal to 300 minutes, yeah.
and then the alternative would be it's greater than.
Correct.
They're looking for. Okay.
Yeah.
It just threw me off. They said greater than, like.
Well, and I always think of it as, what would the skeptic say? No, it's really 300.
Oh, okay.
That's your null hypothesis.